Um, Good evening, my YouTube viewers. It's Crystal here. I'm just here this evening because I want to give you another code review. And this code review is going to be on a Kaggle Playground Competition, Season 3, Episode 25. And what I've done is I solved the problem using Jax Regression model. And what I will do, I will leave a link to the Jupyter notebook in the description box down below if you would like to look at it and perhaps follow along with me. So the regression is regression with a Mohs hardness data set. So I thought that Moh was going to be something similar to an ohm to do with conductivity in electronics, but the Moh is actually a scale of mineral hardness. The Moh scale of mineral hardness is a qualitative ordinal scale from 1 to 10, characterizing resistance of minerals through the ability of harder material to scratch softer material. So basically that's what a Moh is. I didn't know what a Moh was, so I thought, well, maybe I should look it up, because the thing is, it's like when you are involved in data science, when you're working with models and data sets and things like that, you need to be familiar with what it is that you are working with. And so I thought, well, since I don't know what a Moh is, I might as well look it up, find out what it is, and it'll give me a little bit more understanding of what a Moh is. And then, so whenever I ran the model up, my best score was 85 percentile. And so that's not the best score on the leaderboard, but it's because I used Jax linear regression. If I wanted to use another regression model, there's a possibility that I would have a higher score because, like, for instance, there's lots of regression models out there like random forest and decision trees and support vector machines and things like that. But I just chose to use regression since this is a regression model. And so if you this is Jax, but if you wanted to use another module in sklearn, there's a possibility that you could score higher. But since I'm working on Jax, that's what I decided to use was Jax. So the problem statement is predict on Mohs hardness, and the hardness is a scale of 1 to 10 through the ability of harder material to scratch softer material. So that's your problem statement. And then what we do is we create our Jupyter notebook, and when we create our Jupyter notebook, we have to import the libraries that we are going to need to execute the program. So we're going to import pandas, which creates the data frames and processes the data. We're going to import NumPy, which wasn't really used in this program because I used Jax NumPy, but NumPy creates NumPy arrays, and it also makes numerical computations. We're going to import Jax, which is going to create the linear regression model. We're going to import jax.numpy as JMP, which is very similar to NumPy. It's similar to NumPy, but it's not exact. And then we're going to import from Jax, import JIT, which I didn't use JIT in this occasion. I decided not to use JIT. But what JIT does is it speeds up your code. But I had originally started out using JIT, but I decided not to. So from Jax, we're going to import random. That's going to be our random number generator. And then we're going to, from SciPy stats, import KS2SAMP. That's Kolmogorov. And what that does is that performs the Kolmogorov-Smirnov test to see if any of the columns of data aren't from the same data set. and I ran the test, but I decided not to do anything with it because I was hoping that it would improve my score. And matter of fact, it did improve my score when I decided not to do anything with it. We're going to import sklearn model selection train test split. So what that does is that splits your data set up into training and testing sets, or training and validation sets. We're going to import OS, which goes into the operating system to retrieve the files. We're going to import matplotlib.pyplot.splt, which visualizes your data. And we're going to import seaborn SNS, which statistically visualizes the data. So the first thing we want to do is, since we're using Jax, we want to set our key. So key equals jax.random.prng key 42. So that sets a random number. Then we're going to use OS library to retrieve the files. And we have 3 files: train, test, and sample submission. We're going to use pandas to actually read the files and convert them to a data set. So you can see train, and then we're going to, convert to a data frame, and then we're going to have 3 data frames that we're going to convert it to, being train, test, and submission. So here's your train file. It's 13 columns of data. The very last column of data is hardness, which is your target or your label. We're going to see what each column of data is. So each column of data is a float, except for the ID, which is an integer. So that means we don't have anything to encode. So we don't have any object or string columns. So that's good because it's less to encode. So we're going to check for any null values. We don't have any null values. So that's good. No null values. Now we check for the test file. The test file is the same format as the train file, except for it does not have the hardness column, because that's what we're going to be predicting on. We check all the different columns in the test file. You can see they are the same format as the train file. So they're all floats, and the ID is your integer. So that means that nothing to encode, so that's good. So we're going to check the test, check for any null values. We don't have any null values, which is good, which means we don't have anything to impute. Now we're going to check the submission. This is what Kaggle wants to see when you submit your work. So now what we're going to do is we're going to analyze the target. Target equals train.pop hardness. So basically hardness is going to pop out and it's going to be your target. So then we're going to analyze the target. So SNS.disk.target KDE equals true. And this is what it looks like. So it goes from 1 to 10. Now we're going to perform the Kolmogorov-Smirnov test. And when we perform the Kolmogorov-Smirnov test, we have 2 columns of data that are not from the same data set, which is ID and RVDW element average. But I decided not to do anything. You can drop it if you want to drop it, but I decided not to drop it because I was hoping that my RMSE would improve, and it did improve when I didn't do anything with it. But that's just to show you how to do it. We're going to drop the ID because you don't need the ID. The reason why is because in pandas, every row of data is automatically indexed. So I thought, oh, it would be great to do a scatter plot. So we're going to do a scatter plot of total density and the target. So you can see that well, there's a scatter plot of the total density and the target. So it looks great really, but that's your total density. which is between 0 and 600, and then your hardness is your target. We're going to do a scatter plot of the atomic weight average and your target, so you can see that. And then we're going to do a heat map. And when we do a heat map, you can see that some of the columns of data are highly correlated. And if I had wanted to, I could remove the really highly correlated columns of data, but that might not improve the score. So since it was only like 13 columns of data anyway, or 11 or 10 columns of data anyway, I decided not to remove the columns of data that had a high correlation. But if it was a large data set that had a lot of columns of data, and then you could remove the columns of data that have a high correlation, but then you're taking the chance that your accuracy is going to be lower. So this is your core, so you can see your core, your correlation between all of the different columns of data. If you have anything that's higher than a 0.95, it should be removed. Oh, you've got one here. Allocations average. All electrons average is 0.99. So in theory, I could remove the column of data that has a really high correlation, and that it might improve your score. You never know. I mean, I could try to remove it, see what happens. But we do have definitely one column of data where the correlation is almost 1. Now we're going to define our x and our y variables. Your y is your target, your x is your train, your x test is your test, and then x, y, and x test are going to be converted to Jax arrays. And now what we're going to do is we're going to use standard deviation to scale the x and the x test. So now x becomes, after it's scaled, it becomes x scale, and after x test becomes scaled, it becomes x test scale. And since Jax arrays are immutable, it's more difficult to work. It's difficult to manipulate a Jax array. So you see right here, we say mean x equals x dot mean, stdx equals jnp dot stdx, x scale equals x minus mean x over stdx, and then there's your x scale. We did the same thing with x test, made an x test scale. So now what we're going to do is we're going to use sklearn's train test split to split the data set up into training and validation sets. And then we've printed off the shape so you can see the shape of that. So you can see that we have 11 columns. Now what I have done, I think that I have used all of my submissions for the day. But what I might do tomorrow, when I get 5 more submissions, I might go through and remove that one column of data that is 0.99 and see if that will improve my score. You know, that you never know, it might do it, but I won't be able to do that until tomorrow because I have used all of my submissions for the day. So now we're going to come up into the linear regression model that we have created with Jax. So the def normal equation is your linear regression. Beta equals jnp dot dot, jnp dot linear alg dot inv, jnp dot x dot t comma x, comma jnp dot dot x dot t comma y, and then it's going to return your beta. And then we're going to make a prediction. So def predict equals x test beta, return jnp dot dot x test beta. So now what we do is we're going to actually predict, we're going to train the model, and we're going to train the training data into the model. So beta equals normal equation, x train, y train, and then we're going to predict on the validation set, y-pred equals predict x val beta, and then we're going to flatten y-pred. So you can see what y-pred looks like. We're going to find the RMSE, that's right mean squared error. You have an RMSE of 1.4, and then we're going to use Seaborn to create a histogram of y-pred. And so see, here's your histogram. It goes from 1 to 9, which is what I want, so there's no 10s. And then what we do is we use Matplotlib to visualize the linear regression line against the actual data. So you can see that as well. Okay, so now we're going to predict on our test set. And then so predictions equals predict x test scale, comma beta. And then we flatten our predictions. We use Seaborn displot to create a histogram of the predictions. So the predictions are between 0 and 10 or 8, but you can see that what they really want is between 1 and 10. So it doesn't want a value of 0, a value below 1, and it doesn't want a value above 10. So what we're going to do is we're going to clip it. So predictions equals jmp.clip predictions. 1 is your lower and 10 is your higher. And then we're going to create a displot with Seaborn of it. So you can see that you've got your predictions between 1 and 9, which is better. And now what we're going to do is we're going to prepare our submission. Submission hardness equals predictions. Submission.toCSV over submission.csv index equals false. Submission equals pd.readCSV submission.csv and submission. And this is your submission. And this is what we submitted to Kaggle. And when we submitted it to Kaggle, we've got 85.6%. But what I might do is I might try to remove the column of data that has really high correlation and see if that improves my score, but I won't actually be able to run that until tomorrow. And the reason for that is because I've used all my submissions. So since we've done the code review, I want to go ahead and conclude this video. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. Thank you very much for watching my video. If you want to be notified whenever I make new videos, please tap onto the subscribe button next to the bell button, and I will communicate with you in the next video.